Oh, just the proportions. I texted Josh that the other day when I was there. That's not the same picture. Okay. All right, good morning. I think we're gonna get started. So if you didn't notice by the screen there, we're gonna do a live stream. This is the first time I've ever done this. So hopefully it goes well. That means, keep the language and everything under control. Like, I know everybody's wild here, so just keep it under control. This is kind of a really important event, I think, and we try to push it out as much as we can. Everything changed on Monday. So everything changed, and with Apple. So for the first time in 30 years, basically 3 decades, Apple changed their file system. And for good reasons. I mean, it's actually really nice when you get into the file system itself and you understand what it does. It's amazing. It actually just works better. It's the next evolution in file systems. So that for forensic examiners makes it really difficult. So there's not any really good solutions out there right now. Well, save what we've done, from here at SUMURI. So I'll talk about that, but I want to go into what it means and all about Apple imaging, because even before APFS came out, okay, everybody was having problems with imaging with Macs because of core storage and fusion drives and all that fun stuff. So I kind of want to go over all that with you guys and then kind of go over the options, and then I'll take any questions you may have and demonstrate some things. But I always said, and I've been saying it for years, ever since I've been into this, you need to process a Mac with a Mac. And I say it every time, and everybody's like, yeah, because we're all trained on Windows, for instance. Yeah, we're going to process. And then I'm like, guess what? You don't have a choice anymore. You're done. You're going to have to use Mac or Mac OS to do your job now. Like, literally as of Monday, when Apple released the file system, when everybody upgrades to APFS, anybody that has Windows forensics tools, you're done. You're done. And that's scary, because when you're dealing with, what we do with law enforcement, that's a problem, and we don't want that to happen. So we'll tell you what we can do from our end, and then what you guys can do from your end. And then hopefully everything's just going to be fine. We can all hold hands and everything's going to be good. Law enforcement criminals, they're just going to behave from now on and not use Macs, right? So, all right. So we're going to cover Mac forensic imaging is what we're going to do. But let me introduce myself. So my name is Steve Whalen, if you don't know me. My background is in law enforcement. I had over 15 years with Delaware State Police. Was in high-tech crimes there. Way back in like 1997, we started getting fed, or I started getting fed computer crimes. And, I had no training. So I asked for training, went to a great organization, IACIS, to get my training certification, and been a part of that organization ever since. And then just eventually went out and started doing more and more stuff, just getting active in the field, giving it back to the forensic community, and eventually went out on our own, and formed SUMURI. So you may know SUMURI from stuff like Paladin. So we're the originators of Paladin, which we give, it's Linux distribution, which we give away for free. Most of you guys probably use it for imaging, which we got to talk about that too, if you're doing that or using similar disks. Recon, which is our Mac platform, Carbon Virtual Forensics, and Tolino workstations. So enough of that, and let's just get into it. Now, this is for the people that don't feel like watching the live stream or sitting in this class for very long. I'm just going to get straight to the point, and this is it right here. So Apple released, as I said, their first new file system in over 30 years. So previous to this was HFS or Mac OS Extended, right? So this right now is their first new file system, and it's changed. Here's the second key point. No Windows forensics tools that I currently know of, like maybe there's something I don't know, but everyone that I've been able to talk to, and is just no current Windows forensics tools supports APFS natively. So you can't do what we usually do with like HFS file systems or exFAT file systems or NTFS file systems and just throw it into your favorite, forensics tool. You can't do that. As far as I know, and from what I've heard as of, a few minutes ago, and checking with all the wonderful other companies that are here at Microsoft today and at the Northwest ICAT conference, no one supports it. Everyone says, yep, it's on our to-do list, so I'm sure it is, but we don't know when it's going to be released. So that's the key point right there. So Mac with APFS, you use Windows forensics tools, it's not going to happen. So it's just not happening. So we will have a solution for you at the end. So stay tuned. We'll have a solution. We're not going to leave you hanging. All right. So now the other part of this, in order to forensically analyze a Mac has to be involved at some point in the equation. So there's a process that we do, right? There's an equation that we do to actually make a forensic image of a Mac or process or analyze a Mac. I'm telling you now, at some point, Mac or Mac OS has to be in your equation. You no longer can do stuff without a Mac involved. One way or another, no matter which way you do it or which way you approach doing the analysis of a Mac now, you got to have a Mac or Mac OS in the equation. You don't have a choice. Now, why is this important? And again, for those of you that are watching this broadcast live, I'm speaking to a bunch of law enforcement officers and investigators, and budgets are always a concern. So budgets are concerned, and when you walk up to your supervisor and you say, hey, we need a Mac, they're gonna be like, yeah, right, so do I, go back to your desk. It's not gonna happen. So I know you guys have probably been asking for a long time, we need a Mac, and if you haven't gotten one yet, please do. Like, whichever way you can do it, get a Mac in your lab. You're going to need to have a Mac in your lab, okay? Again, we're gonna do our best to kind of help you get through this situation until you get all the tools that you need. So I'm just hang tight. But anyway, if you see the little screen there, I got like a big equation. That's what it takes to do Mac forensics. And there's a Mac in the middle of it, just in case you don't get the point. A Mac has to be in your equation. Everybody got that? Good. You guys have your coffee yet? All right. Now here. All right. So there's no question. We're just going to speak about reality here. There's no question that Windows forensics tools dominates forensics right now. It always has, right? So if you look at the types of like Mac forensics tools available and Windows forensics tools, there's more Windows forensics tools than Mac forensics tools. That's just the way it's always been. Okay, and it's probably going to be that way for a long time. Okay, it's just the way the world works. Now that kind of sucks because Mac, or I guess Windows forensics tools, have been losing ground in doing Windows or Mac-based forensics on Windows tools or in the Windows environment for quite a long time. Okay, and I'm not here to bash Windows or Windows forensics tools, and I'm definitely not saying don't use Windows forensics tools. I'm not saying that. There's a lot of good tools out there, and we here at SUMURI always preach, get as many tools as you can in your tool chest and use the best features of each tool. Like, get as many as you can. But I'm just telling you, there's limitations to Windows forensics tools or looking at Mac stuff on Windows or in Windows forensics tools. Okay, and it gets worse. So starting with 10.4, so just so you know, Monday 10.13 was released. Okay, back in 10.4, we're talking like a long time ago, Apple released something called Spotlight. So how many Mac users do we have in here? Yeah, I was gonna say you're holding a Mac, so you should raise your hand. Okay, all right, cool. So we have Mac users here. If you're not a Mac user, so Mac has a really cool indexing engine that's called Spotlight. It's been around since 10.4, quite a long time. Now, the question is, how does it work, right? So what little magic goes on behind the scenes that makes Spotlight work? That little magic stuff is not properly interpreted by Windows forensics tools. That little magic stuff that if you're on a Mac or you're using a Mac that you can see solves cases. So I'm doing another lecture just after this one tomorrow. It's going to show you some of that magic stuff that you can use to solve cases. So here at this conference, at the Northwest ICAC conference, Internet Crimes Against Children, my job is to help you determine what happened and put the bad guys away. And as I say, I like to find every little piece of artifact that I can to put the final nail in the coffin. So if somebody's done something bad, especially children, we want to make sure that they don't do that again. And we give out every piece of evidence that we can find. And on the Mac, it's easy. It's so easy. But the sad part is with Windows forensics tools, because they don't fully support this type of data or recovering this type of data, you're at a loss. So that again, started way back in 10.4. Then got the introduction of fusion drives. So we'll talk about what fusion drives are. I mean, it's a great thing, but that Apple needed to do something again different. So they used something called core storage. So not too many Windows forensics tools picked up on this. And if you have like a multiple disk core storage of situation or drive, you're not going to see it in a Windows forensics tool. So back then I started saying, hey guys, start using Macs because you got to have a Mac in your equation. You're not going to be able to start doing forensics anymore with your Windows forensics tools unless you start using a Mac. So somewhere you have to do it. So that was, again, quite a long time ago when they started introducing core storage drives or using that format for multiple disks. And then now, okay, APFS, so Apple File System. So again, absolutely no Windows forensics tools support. So again, a scary thing. So, but again, by the way, if you haven't figured out my picture, I like to put little visuals. I'm a visual person there. So that's APFS. And the people on the train, that's you, the Windows forensic examiners. And he's going nom, 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 nom. So if that should just drive the picture home, okay? All right, so let's talk about this a little bit. So the number of Apple computers, I tried to look this up the other day. So since 2006, Apple's apparently sold 4.3 million. I don't know if that's accurate. That's just something I found on the web. So that's still a lot of computers, and especially in West Coast where we are, like everybody's got Macs. It's like the cool thing to do, right? So the majority of computer forensics, like I said today, is done on Windows-based file systems, and I know why. It's because in the very beginning, and as this area kind of was one of the originators for just forensics in general, computer forensics, and everybody was using Windows. It's just the way it was. I was the oddball that was given a Mac way back in 1989 and just continued to use a Mac. So when I went to Windows forensics training, you know, everybody was teaching how to do stuff on Windows. I'm like, well, how do you do that on a Mac? And I got stuff thrown at me. So I stopped asking questions and just figured it out myself. But the majority of forensics trainings that you guys get is on Windows. So you do what you know. So when you actually, go back to your lab and a Mac comes in, then you just try to apply your Windows forensics techniques and tools to the Mac. So that's a problem, okay, especially with some of the things I already suggested. So now, the issue that you're going to have, again, it's not that it can't be done up until now, okay? There's to the point where you're starting to encounter things with Mac technology or Apple technology and hardware and file systems that you just can't force into a Windows tool anymore, okay? So, and then when you actually can force it into the tool, it's kind of like, again, the picture I like to show is a square peg going into a round hole. So you can kind of make it fit if you hit it hard enough, but when you do, you're missing pieces. And those pieces, the little pieces that you see there, could be really important bits of evidence that could just like instantly solve your case. And there's that kind of information that exists on a Mac, like stuff that just instantly solve your case if you can see it. So wouldn't you like to know that instead of spending a month to do your job, that you can spend 5 minutes and do the same thing? I got things to do. I know you guys have a caseload. That's why we need to talk about it and get you on the same page. So, okay, no pun intended here, but the Windows file system and the Macintosh file systems, it's like apples and oranges, okay? It's a joke, okay? All right, so Windows doesn't really care to interpret any of the Macintosh file systems, so APFS or HFS or macOS Extended, right? It just doesn't really care. You plug it in, and what does Windows do? Yeah, I don't know what this is. You want to format it? Like, to get this out of my system. We can make it NTFS or exFAT. So yeah, they don't want to deal with it. So no big deal. It's not that, again, and I've learned this. It's and I know a lot of people are laughing that I'm actually doing an Apple broadcast, me being the Apple guy, like, for forensics at Microsoft. But Microsoft's cool. I like it. Like, it's a cool campus. They take care of you here. They feed you. It's all good. And then actually they have a whole division for Apple. They have a whole division. They work hand in hand. I didn't know that, but that's good to hear. So that's great. So anyway, it's not that like I'm assuming that they don't really care, but it's just in their business model, it doesn't make sense to interpret it. They do their thing, Apple does their thing, and they interact in whatever ways they do. But for us as forensic examiners, if you're trying to do forensics, you're doing it on a Windows forensic system, it's just not going to work so well, okay? So because of this, you're going to miss valuable evidence and time. So again, I'm not saying, please don't get me wrong, I'm not saying don't use all those great Windows forensics tools out there. I'm just saying, know the limitations of each tool that you're using and be prepared for that. Be prepared for that. And then use other tools or systems that do work. Now, to make things even more difficult for us, the technology that's out there. So if anybody has a newer Mac, we have one here that we're using. I'm using one right now. They've switched the hardware. Apple's like stays on top of hardware and new technology. So there's some Macs out there like this one, like we have a 2016 Touch Bar and a 2017 Touch Bar, and the only ports on it are Thunderbolt 3 ports, which is like a USB-C type interface. So basically, that's being used for your power, your video output, your data transfer. Like everything's being used on one port. So again, it makes sense. And if you're on top of mobile phone technology for geeks like us, or a lot of the mobile phones are moving to that default technology. I mean, it's a great interface. So you don't have to worry about which side, if it's upside down, if you're plugging it in, if you've been drinking or something. So it all just goes in whichever way you want. So very, very good. But the problem is that, and I'm going to hold it up here, you need adapters, okay? And they're kind of expensive, and you have to be careful with these adapters. For those of you that are doing imaging or forensics with Macs and you're using various adapters so you can connect standard hard drives that don't use the same interfaces, okay, be careful of the adapters that you use. I can tell you right now, some of the cheaper adapters, I'm just going to say, may burn your logic board, so your motherboard, and may cause damage. So I would kind of test these things, and I can tell you the ones that we've used. I've used obviously Apple adapters, which I'm not plugging them, but Apple adapters are tested. We've used Hootoo. It's Hootoo, and you can get these off Amazon or any of your favorite stores. And then AllKey. So those adapters I've used with no issues. But be careful of grabbing any just regular adapters and using it for imaging, because I have burnt up a brand new MacBook, my own, not evidence, but burned up in testing one of these things. We tried to make our own adapters to give out with our products, and those adapters, even though I told them, don't give me the bad ones, they gave me the bad ones, and it burnt my MacBook up. So not good. So be careful with the adapters. But this is a problem. So when you go out to image, especially if you're on scene, make sure you bring the proper adapters that you need. Something else that's really good, and these just came out, and we use these for our other products as well, is the Samsung T5 drives. So we use this for our Recon and Carbon products, and they give you two cables. So the type A to type C and type C to type C. So these are awesome drives, like 540 megabits per second. So anything like that you can use and eliminate adapters is better. So just keep that in mind when you're doing imaging, because you never know what's going to happen.
We have a question.
Oh, got a question.
Aaron Scantling, can Steve give any examples of information that might be lost when trying to access HFS plus images and a tool like FTK, like all the metadata?
Oh, yeah. So the question is, we have someone on a live stream asking a question, like what information could be lost? We're actually covering that in another lecture tomorrow. Some of that information is lost, but really quickly, the answer to that question is Apple extended metadata. So Apple makes more, records more information about the files on the system. That is a separate indexing that occurs, and many forensics tools, most Windows forensics tools, don't recover all that pieces of the types of metadata. So an example would be where a file comes from, or what device it was taken from, or what applications it was passed through before. Was it airdropped? That kind of stuff. So some applications, some Windows tools don't recover. There's hundreds of extended attributes out there that actually can be recovered, and some of the Windows forensics tools recover maybe 2 or 3. So that's it. There's hundreds that are being missed. So that's should be the short answer to the question. Now, going back to the technology part to make things a little bit more difficult for us, aside from all the file system changes, something for the example of the MacBook that Apple sells right now. It's a monolithic design with a single USB 3 port, or USB or Thunderbolt 3 port. So a single board, like what you see in there, that picture, that's with everything else removed. That is it. That is actually smaller than a Raspberry Pi board. So that's how tiny it is. And it's monolithic. So for those of you that are used to I'm going to get a Mac, I'm just going to crack it open and remove the hard disk, just forget about that. So just forget about that. Yes, I'm sure you're familiar with blades and the NAND flash that's being used and stuff, but this is all integrated. This is all soldered together. So start thinking like you would, approach it as like a mobile forensic exam. And as far as I know, I don't know of any way to chip off or any other technology to pull data from this that, forensic examiner's been using. So, if you have the idea that, well, I'm just going to take it apart and pull the drives off of these and image them, put it into my system, that's not going to happen. Okay, and then with this particular Mac itself, it's got one port. So you got to think about that as well. So it's just another challenge that we have thanks to Apple and their new technologies. So, I mean, again, it's all great things for great reasons, but it makes it more difficult for us as examiners and to make a forensic image. So let's kind of like get into it, and I'm going to start out with everything that was there prior to Monday. So let's start with the old stuff, right? Let's start with what was there first. So I told you there's a few things that actually started causing problems for Windows forensic examiners doing Macs. So I talked about the extended metadata with Spotlight. That was something that's being lost. Then I talked about core storage and Fusion drives, and then APFS. So let's go over the old stuff, the stuff prior to APFS that was released Monday. So when you stick a disk into a Mac to initialize it, so in the Mac world, we say initializing or formatting, right? So when you stick a disk in, you had a few options to format a disk. And you see those options here. So you see Mac OS Extended, and for those of you that are old school Mac users like me, that's just HFS, so hierarchical file system. So, but of course, we're cooler now, I guess they use longer terms, makes it sound better. So you see a lot of different versions of Mac OS Extended. You see exFAT in there, right? And then you see MS-DOS FAT, so FAT file systems. So when you stuck a disk into the Mac through the disk utility, which is used to format a disk in a Mac, that is the options you had. Those are the options that you had to deal with. So 6 choices, and we'll talk about some of the other options areas like journaling, encrypted, and case sensitivity. Now notice that NTFS is not an option in there. Okay, so that is not something that Mac will allow you to create a read-write image of. So you can read from it, but you just can't write to it, so it's not in there. You can use third-party utilities to actually add support for NTFS, and there's lots of great tools out there to let you do it. Not that expensive, and we recommend it in the forensic world. Like if you're going to be doing Mac and Windows, examples like Texera would be one, and Paragon would be the other, the two that come to the top of my head. Now, here's where it gets tricky when it comes down to imaging. So we got to understand what's going on underneath before you can actually just start jumping in and deciding what the image, because now choosing what the image becomes a really difficult question if you don't understand what's going on underneath. So there's these things called partition schemes. Okay, so when you format a disk, most of the times this is not even an issue. Like you don't even see it. So you don't even know that this exists. But every disk that you format has a partition scheme. Okay, so it has nothing to do with the volumes. Okay. It's the actual, like say, wrapper around the volumes itself. It's the way the disk is actually prepped. And the purpose of this disk, like the actual partition scheme, is to let a particular device be bootable or not. So the real simple answer to this thing or explanation is if you're not going to boot a device with a particular disk, then don't worry about this. Okay, there's no reason to worry about this. If you are going to boot either a Windows PC or a Mac or something with a newer, like the EFI, the UEFI, then you do need to know about this. So again, it comes into question if you're going to boot a device, that's when you need to know about the partition scheme. So then you do have an option for choosing partition schemes in the Mac. So, okay, now what's important for us, I guess just for understanding, because I remember when the new GUID partition scheme came out for Mac users. And then when us as forensic examiners, when we got these drives in, we saw this extra partition on the disk and everybody was freaking out going, what is this? Like, why do I have this partition here? What's it for? Why is it here? Well, it's part of the partition scheme and you got to understand. So you see there's an option for a GUID partition table. So that's for all the newer Intel chipsets, right, that Mac has moved to. So they use something called a UEFI or EFI instead of like an open firmware, which they used before. So it's kind of like their BIOS, right? And it exists both on PCs, current PCs, and Macs. But if you want to make any of those Intel type devices bootable with a disk, then you have to choose a GUID partition table, which actually makes changes or certain partitions on the disk that you're going to examine. So it's good to know what that is, and I'll show it to you in a second. APM or Apple Partition Map, which you see here, that's for the old school stuff. That's like prior to 2007. So back before 2007, Apple used different chipsets, Motorola chipsets, which used something called open firmware as like their version of their BIOS. And that required an Apple partition scheme, an Apple Partition Map. And then you have your master boot record, which most Windows forensic examiners are familiar with. So just keep this in mind because aside from the APM and MBR, you're not going to see anything on the disk. You will see something new on the disk with a good partition table. So anything for Intel Macs from now into the futures, including APFS, APFS uses a GPT, so a good partition scheme. So we're going to show that here. So again, a visual picture here to kind of help you out. So looking at the gray area on this particular image, that's going to be your disk. Like, let's imagine that as your hard drive, okay? Now, the yellow ones that you see there, that is going to be your different volumes, right? Your different volumes. And it could be anything. You can have Mac OS Extended. You can have a FAT partition on there. You can have exFAT partition. Okay, you can put whatever partitions you want within the actual disk itself. Now, the question becomes here, what is the partition scheme and why is it important? Again, if you want any one of those volumes to be a bootable volume to actually boot that device, especially a Mac, it needs to be a GPT. So anything from 2007 onward, it needs to be a GPT. Okay, a good partition scheme. Okay, so just hopefully that will help you understand. Now, let's talk about Mac OS Extended just a little bit. So prior to Monday, for the rest of the world, prior to Monday, okay, Mac was using what's called hierarchical file system, which they renamed or started calling Mac OS Extended or Mac Extended File System. So again, for us old users, you're familiar with like HFS Plus is kind of what the nomenclature was. It has similar features to FAT32 as far as how it works. It's been used in Mac systems, Mac operating systems since 8.1. So like way back in the days prior to OS, OS 10, so OS X. So way back in the days. And it has, limitations, file name limitations, 255 characters, allocation block size, 32 bits. And then the one that was most common up until yesterday was, Mac OS Extended with journaling. So journaling is just a method to recover from system failures. Okay, so that was the most common one. So then, enter APFS, which we'll talk about in a second. So let's talk about these options with initializing or formatting a disk in Mac. So using Mac OS Extended. So journaling, again, that recovers from system failures. So it's going to actually, it's like any other journal file system. It's going to take notes before it actually makes writes. And if something happens, it checks its notes to see what happened and then just, speeds up system recovery and avoids data degradation. Case sensitivity. Now, why is that in here? Well, Mac, if you don't know its history, was based on Unix. So since it's based on Unix, when it first came out, the first version of Mac OS 10 that came out, or Mac OS X that came out, was a server-based version, and it was placed alongside of other servers, Unix-like systems. So, and Unix-like systems were case sensitive. So in order to not destroy data and transferring data back and forth, there was the case sensitive option. Now, and it still exists today. Matter of fact, if you're using iOS, so like if you're using any iOS device since 10.3, you've been using APFS on your devices that you're carrying. So unbeknownst to most of you, you've had it in your pocket all along. So it's snuck in there and it's been staying there. And the version that's actually of APFS that's in your pocket or in your iOS device is actually case sensitive, as opposed to the new APFS, which is case insensitive. So Mac systems, Mac APFS is case insensitive. The phones in your pocket are going to be case sensitive. Okay. So an example of this, if you're not getting the importance of case sensitivity, I have two file names that are listed below, myfile.txt and myfile.txt. Okay, one is upper and lowercase characters. The other one is just uppercase characters. On a case sensitive system, they're two separate files. Okay, one would one they would be kept separate and apart. If you put it on a case insensitive system, even though they're two separate files, they could overwrite each other just because of naming conventions. So that's why you have to be careful. So let's talk about Fusion drives. So we talked about Mac OS Extended, okay, or HFS Plus. Let's talk about the entry of Fusion drives. So Apple, several years ago, came up with a great solution to get you guys more speed on your systems, but not pay that price. Okay, so when SSDs started becoming popular, okay, Apple got the great idea, hey, let's give the Mac users the speed of an SSD, but the inexpensive long-term storage of a spinning platter. So they came up with this idea for a Fusion drive. So a Fusion drive has got an SSD, or did have an SSD, and a spinning disk. So your long-term storage, the inexpensive part, all that long-term stuff will be stored in the spinning platter, anything that needs to be used frequently or is about to be used on a Mac system got moved up to the SSD. So you're literally getting the benefits of an SSD without paying for it. Because back in the day, SSDs were expensive. So if you follow the market, SSDs pricing goes up and down. But back when Fusion drives first came out, SSDs were expensive. I mean, obviously the speed benefits were great for SSDs, but it was expensive. So they used the spinning platter to hold the large amount of data, and then they use the SSD just to transfer the information to the OS in real time. So, moved it over there. Now, imagine this. You have two basically physical disks now from a forensic examiner's point of view, two physical disks on a Mac that are in there acting as a single drive. Well, how do you make that happen? Okay. Well, it doesn't really matter for us, I guess, in some respects. Like, we don't care. It just happens and it works. But from a forensic examiner's perspective, it freaked a lot of people out when Fusion drives first, came into being, because you saw two physical disks. So from a normal examiner's perspective, you image the physical disk. So you make a physical image of the SSD, you make a physical image of the spinning platter. Voila, I'm done. And then guess what? You put them in your forensics tools and you can't see anything. All right, you just see a bunch of gibberish. So then that's the beginning of where things got worse. For Windows forensic examiners, or trying to approach Mac forensics from a Windows side. Okay, so you have these two physical disks. Now, this is where I started screaming at people, a Mac has to be involved in the process, okay? If you have a core storage drive and it's a multiple disk core storage drive, you gotta have a Mac in the process. There's no Windows forensics tool out there that can take those two pieces and put them back together again. So somewhere in the equation, the Mac has to be in the process. So again, we have a product out that's called Paladin. And we created Paladin. It goes back to our Raptor days of just making a disk that we can give out to the forensic community, specifically law enforcement mostly, to help them have great tools and if they had no budgets whatsoever. So Paladin and Raptor 4 are based on Linux, okay? And Linux, okay, does not support core storage, like multi-disk core storage. And I'll tell you a funny little to-do or aside in a second. So, but Paladin could image those two pieces, and then to recreate what Apple sees, you had to bring those two pieces or those forensic images back to a Mac, and you can use the Mac to recombine them and then image it out again. So that takes time. I mean, but it was done, right? It comes down to what tools do you have, what budgets do you have, that kind of stuff. So that was a way to do it. Okay, and we'll talk about another way to do it in a second, which is much better. But again, you could still handle core storage drives. So you image the physical disk and you just bring it back to a Mac, recombine it, and the image out again. And then you can put it into your Windows forensics tool. Okay, now the crazy thing is now that because SSD prices have dropped, Fusion drives don't have to be a spinning platter, like traditional spinning platter. It could be two SSDs. You could actually, if you want to, use multiple disks to make a Fusion drive. So this isn't the right explanation of it for the technical people out there, but for those of you trying to wrap your head around what is a core storage, like a multi-disk core storage volume, imagine like a 2-disk RAID. Just imagine that. You're taking two separate disks and making it one volume. So a simple 2-disk RAID. Just think of it that way if you're having trouble understanding what core storage is. Now, let me freak you out a little bit more. Okay, so imagine if a Mac only has a single disk. Okay, so prior to Monday, for this past Monday, so if a Mac has a single disk, guess what? They still use core storage. So what the heck, right? Like, what the heck's going on? So that's another problem. So I got a lot of phone calls, and again, if you're familiar with our Paladin product, we give it out to the world for free. So free is good, right? So a lot of people use it. So we give it out to the world for free. So everybody's imaging these like Mac systems, right, with Paladin, and then they're put into Windows forensics tools and calling us up and going, Paladin's broke. And I'm like, excuse me, what do you mean Paladin's broke? Well, I put it into this tool or that tool, and I can see the ESP, which we'll talk about in a second. I can see the recovery disk, but where the user data is, it's all gibberish. So Paladin must have done something. It broke it. I'm like, well, did you check the hashes? Oh yeah, the hashes are fine. So the hashes matched. Like, you made a good forensic image. So I'm like, then no, everything is good. Everything's good. So then I had to explain to him that about core storage. Now, I said it's kind of funny because I said Paladin doesn't like natively support core storage, Apple core storage, right? But guess where core storage came from? Unix and Linux. That's where it came from. It originated. So what Apple does, if you don't know, and you haven't used, if you've ever taken any of my presentations, Apple uses a lot of open source technology. They're smart. They're super smart. Hey, let the rest of the world make something, and we'll put a little twist on it, and we'll put it out there, regurgitate it. Now, it's smart in a business sense, and it's also smart in a sense because they won in the end. I'm not going to say this, they won in the end. Because when Windows was dominating everything, and I'm not bashing Windows, I'm really not bashing Windows. When Windows was dominating everything, they were trying to set standards. Like you're going to use Microsoft Office, that's the standard. Like that's it. Everyone's going to use documents. And guess what? Microsoft is now using a lot more open source standards. They're reverting back to open source as well. It just makes sense. It's like kumbaya with the peace with the world, right? Linux uses open source. Mac uses open source. It just makes sense for Windows to use open source. And they are. So everything is kind of coming together fine. And it's the same way that if you're doing forensics now, I can tell you if you examine two types of files and you understand these two types of files, you could be great forensic examiners. So XML files orplists in the Mac and SQLite databases, everything, phones, mobile devices, tablets, Mac OS, Windows OS, they're all Linux OS. They're all using those. So if you understand those two file types, you're way ahead of the curve. You can analyze anything. So everything is coming together open source, but that's the key point where you got to understand. Apple takes open source technology and puts their little twist on it. That little twist makes things incompatible with other tools, and that's where it's kind of difficult. So that particular open source technology that I'm talking about is called an LVM, a logical volume manager. So it's been around in Unix for quite a long time. Again, like at least 6 or 7 years. It's been out in Unix and Linux, An LVM, a logical volume manager. So core storage is an LVM with Apple's little twist on it. They add their little magic to it, and it does what it needs to do. So it was introduced way back in Lion, so Mac OS Lion, so back in the day. Now, the primary purpose of the core storage was to support Fusion drives, but the problem is, like I just said, even if it's a single disk, in most circumstances on Macs, it's still using core storage. So when you put that little twist on it, and then you try to import that into tools that don't support it, that's a problem. Now, I am happy to say, I do teach alongside of other great companies out there with lots of great tools, forensics tools. Most of the popular forensic tools out there, Windows forensics tools, do support single disk core storage volumes. So if you have the latest versions of all those popular tools out there, most of them support single disk core storage volumes. But guess what? If you have a Fusion drive, a 2-disk core storage, or more than 2 disks, for instance, if you have someone like Ryan sitting in the back that just does crazy things, then guess what? None of those tools are going to support it. So no one can bring them in, none that I know of. And if I'm wrong, please let me know. So I'd be happy to tell that there's something that supports it out there. So that becomes an issue for us. So we're gonna talk about this. So at this point you got to understand, and this is where you have to understand if you're using certain tools to do images, what tools are you going to use to image, and what are you going to grab? Are you going to grab the physical disk? Are you going to grab the volume? Are you going to grab are you using a Mac-based imager? Are you using a Windows-based imager? Are you using a Linux-based imager? Are you using a hardware-based imager? Is it going to work? There's a lot of questions that are coming up now. And for those of you who've been doing this for quite a long time, like 20 years like me, you might want to retire. Like just cash out, retire, and just don't worry about it anymore. Just go get that drink. And so, yeah, I got one hand going up. I'll join you soon. So if anything else happens, we, not to plug anything here, but we just developed with Tolino side a 1.2 petabyte server. A 1.2 petabyte server, like my first drive, my first case was a 12 gigabyte child pornography case. 12 gigabyte. Now we have a 1.2 petabyte server that we make. That is insane. So like, yeah, if somebody dropped it off my doorstep, I'm like, nope, done, I'm good. I'm gonna retire. I'm gonna pass along to somebody else. All right, so this is, again, with the core storage, this is where things get complicated. So let's take a look at what we have right here. So I did a screen capture. So what you're seeing in front of you is an Apple terminal. So we drop down to the command line. And I'll be the first to tell you that I don't like command line. I know enough to be dangerous. That's about it. So we're using a simple command called disk-util-lesc. And this is on a non-APFS system. This is just a regular drive. So now let's just look at this from a forensic examiner's perspective here. And I'll even ask you guys, okay? So let's talk about the Apple naming convention really quick. So Apple starts naming their disks, like starts with 0. Like so many times in forensics, we start counting with 0, right? So disk 0, we would think, so dev disk 0 would typically be your first disk, right? And then we see here we have a dev disk 1. So that would be your second disk, right? And then we see a disk 2 and a disk 3. So with you guys being forensic examiners, okay, how many disks do we have here? How many physical disks do we have here, would you think? 3, 4. I heard 3 and 4. Okay, 3 and 4. So 3 is the correct answer. Okay, 3 is the correct answer. But for those of you that I'm hoping are saying, well, I see 4, like I can count. Disk 0 is 1, disk 1 is 2, disk 2 is 3, and disk 3 is 4. Why are we saying 3 disks? Well, because we're using core storage here. So let's talk about what's happening. So if we look at dev disk 0, right? That's, if you look right next to it, says internal and physical. Okay, so that's a good sign right there. It says physical. Remember, we're doing this on a Mac. So remember, most people don't do this stuff on a Mac. They do it on a Windows system or some other tool, right? Or maybe even our Paladin disk. Okay, so internal physical. It's telling you it's internal physical. And if you go down there, you see the 0, 1, 2, 3. Okay, let's start with the 0 is just going to identify the partition scheme. So don't count that as a volume. Okay, that's just the partition scheme. So don't count the 0 in the slices. So Apple calls their partitions or volume slices. Don't count slice 0 or partition 0 or volume 0. That's just identifying the partition scheme. All right, let's start with 1. So volumes start numbering with 1. So the first thing we see is an EFI. Okay, and it's about approximately 200 megabytes in size, okay? So approximately 200 megabytes in size, and we'll talk about those in a second. Then we have slice 3. Slice 3 says Apple boot, okay, boot OS X. That's the recovery partition. Okay, that's the recovery partition for that particular disk. It helps you, it's actually written to the disk itself. And then we have 2, which is Apple Core Storage Macintosh. So now the question comes up, okay, I want to grab everything from this Mac user and image stuff. What are you going to image? Like, what are you going to image? One of those slices, one of those partitions? Are you going to take the physical disk 0? Like, what are you going to do? Well, I have to say to you, it depends. What tool are you going to put it in? You know, are you going to use a Mac? Are you going to use Windows? You can use Linux? Like, what are you going to do? That's like one of the first questions you got to ask yourself. And like, remember, we haven't got to APFS yet. We haven't got there yet. We're still talking about core storage. All right. So now let's go. Oh, and by the way, for slice 1, the EFI, that's actually an ESP. So it's an EFI system partition. So there's lots of acronyms. So ESP, EFI system partition. So the purpose of that is it's actually placed, it's an actual partition placed on a disk that's been formatted as a GUID partition scheme to hold boot time drivers. Okay, it's the whole boot time drivers, device drivers. Apple, as far as I know, hasn't utilized it as of yet. But let's say, you know, with the newer technologies out there, the stuff that used to be contained on the chipsets when you're actually bootstrapping a device or booting a device, right? It may need certain drivers, and because of the newer technologies out there, you may need larger drivers. So that's the holding place for that. It's like the parking zone for those larger drivers. And again, like as far as I know, for Mac users, there shouldn't be anything there of evidentiary value unless somebody's going out of their way to hide something. And I don't think at this point in time Apple is using it yet, but I don't know for sure. Okay. Now, going back to choosing what you image. Well, again, we're looking at this from a Mac perspective, right? We're doing disk util list from a Mac itself. So we're seeing things as we should see them. So let's take a look at disk 1. Okay, let's look at disk 1. So this one says internal physical. Okay, internal physical. So, okay, well, we got another disk, and it says internal. Okay, well, geez, look, it looks like the other one. It's got a good partition scheme. It's got an EFI. It's got a core storage partition, and it's got another recovery hard disk area or Apple boot area or something, right? So, well, crap, which one is it? Which one do I which one do I image now? Or which volume do I image? Or do I do both? Or what do I do? Again, I have to ask you, what tool are you going to be using after this? Like, what are you going to try to put this into? Like, how are you going to process data? How are you going to do it? So anybody taking a guess on what disk 0 and disk 1 is right now? Anybody want to take an idea, a guess of what those two are? An SSD and a spinning disk. Yeah, let's look at the sizes, right? So if you look at the first one up there, right, we see it's about 121 gigabytes in size, and the next one is 1 terabyte. Anybody want to take a guess what we're looking at? I just told you. Thank you. Woo, you are paying attention. You guys are fast learners. Yay. Okay, yeah, so Fusion Drive. We're looking at a Fusion Drive. So perfect. So what we're looking at actually is an iMac that has a Fusion Drive. So perfect. So we have 2 physical disks in here right now. And we're looking at the SSD portion of it and the spinning platter, as you just said. So exactly right. So we have a Fusion Drive here. Now, let's take a look at disk 2. What's different about the naming convention? What's being identified by disk utility? It says internal and what? Virtual. Guess what? So disk 0 and disk 1 are being combined to make disk 2. Is that true? No, it's not true. It's not true. Well, it's partly true. So let's take a look at this. Okay. Go down on disk 2 there and look where it says underneath where it says Macintosh HG, which is the name of my volume. It says logical volume on what? Disk 0 slice 2 and disk 1 slice 2. So go back up to disk 0 above slice 2 and disk 1 slice 2. Are those physical disks or are those volumes? They're volumes. So you got 2 volumes making a virtual physical disk. Okay, so now you're the forensic examiner, okay? Again, what are you going to image? Which one? Are we going to go disk 0, disk 1, disk 0 slice 2, disk 1 slice 2, or disk 2? Which one are we going to do? Disk 2? Are you going to miss anything? So in forensics, and when I asked that question, in forensics, we want to make sure that we get everything, right? So if you image disk 2, the core storage volume, are you getting the entire contents of disk 0 and disk 1? What are you missing? Yeah, so you're missing the EFI and recovery partitions or the boot partitions, right? So in all actuality, okay, most likely there should not be any evidence there from or information there from a user, but be aware that you're missing that. You are missing it. So if you're, depending on what your policies state, you have to get the physical contents of everything, you're not getting that if you image it. But again, the next question comes up, what are you going to be looking at this with? So I think we have another question. Oh, okay, let me read this. This could be embarrassing. Does it show this way if you have a mounted system after disabling disk arbitration with target disk mode? Okay. So if you plug in a Mac, okay, and target disk mode is, so they're referring to disk arbitration. So we're going to talk about it in a second. Disk arbitration is the automatic daemon that's built into the Mac. It's a launch service. So basically, it controls auto mounting of devices that you plug in. So there's been a long-standing method of disabling disk arbitration or controlling or pausing disk arbitration. Connecting device, there's no official mounting of that device. Can you still see all of this stuff through target disk mode? So the answer to that is yes, but not by traditional standards. Like if you're using the GUI to do it, the answer is going to be no. Because remember, what you see in the GUI is basically it's the matrix, right? It's the world that the programmers have given you. So what you really need to do is drop down to the command line, and then you can see everything. Okay, so the answer is yes to that. If you control disk arbitration and turn it off or disable it for temporarily and plug in a disk, can you see all this stuff? Yes, you can. But you're not going to see it in the GUI with traditional GUI-based tools unless they've been modified. Okay. So you're going to have to drop to the command line to see this stuff and maybe use some different commands to actually pull up those partitions, okay? All right, So now back to this again. What are we going to do? Like, what are we going to image here? And that's where it comes down to what tool are you going to use to analyze it? So are you going to use a Mac to analyze it? Are you going to use Windows to analyze it? Are you using a Linux-based imager? Are you using a Windows-based imager? Are you using a hardware-based imager? Or are you using a Mac-based imager? And hopefully by the time I get done this presentation, you're going to see it's just beneficial. I'll just give you the answer to use a Mac-based imager. Like, handle it in the beginning. Don't worry about it in the end. Okay, like just let the Mac do what it does. Okay, that's probably the best way to handle it, is use a Mac-based imager. So, okay, so now, again, if I'm using a Windows forensics tool at this point in time, I got to put it into some sort of format that a Windows forensics tool can see. Okay, so if you want, in this situation, if I have a Fusion disk, and I want to put this into a Windows forensics tool to analyze, since I know I can't take those two physical disk images or partition images, if I made those and try to throw in a Windows forensics tool, it's not going to be recombined. So you have to do the recombination. So to do that, you have to put it back onto a Mac. You can image both physical disks, disk 0, disk 1. You can bring it back into a Mac and recombine it. And then you have to image it out. Okay, again, once it's recombined. Or if you use a Mac-based imager, okay, it will do the heavy lifting for you, see it and mount that internal virtual disk, disk 2 for you. You image that, everything's already put together for you. Everything's already put together for you. Question?
So I have the suspect's Mac, and it's powered down, it shows up to my lab, and now how am I going to determine this if I can't power up the suspect's Mac? If I do power it up, it's password protected. How can I determine if it has a core storage or how to do any of these things?
Ooh,
How do I get to the command line?
good question. We'll cover that. We'll cover that. Just remind me if I don't, remind me to tell you. But I will show you some commands you can run, if I can remember. So we'll try to demonstrate that. Okay, so just hold on to that for a second. All right, let's move on. So let's take a look at this example that we have here, and we kind of discussed it, but I just want to kind of recap for you. Okay, when we see a single disk in a Mac, it's a combination, if it's a Fusion drive, a combination of two disks. Okay, so what we have here, a logical volume, okay, is created. A logical or virtual physical disk is created, okay, with the combination of two slices we see here in this example. Disk 0 slice 2, disk 0 slice 1, okay, makes the logical volume of disk 2. So, and the command I'm using here on a Mac is diskutil cs list. Diskutil cs list, okay? So that's basically stands for core storage. So using disk utility command, the command line version of disk utility, do a listing of core storage devices. And so now it's breaking it down for you. If you follow the little dots and dashes, it's going to say, hey, there's the actual online status of Macintosh hard disk, which is my volume name. There's the full size of the combined data, okay? Then we have two physical volumes below, and on those two physical disks itself, we're taking the second partition or second slice from each one of those and actually combining it into a family, a logical volume family, which becomes a logical volume disk or a virtual disk, which we see as disk 2. And then that's where everything gets together. And down at the very, very bottom, if you see LVG, okay, LVG type, it says Fusion disk sparse, okay? So it tells you it's a Fusion drive. So are we good with core storage? Did I lose you guys? Are you done? You're like, I'm out of here. I'm going to quit now. All right, we'll take resignation letters at the end. All right, so again, like I mentioned before, as examiners, we're trained to image all the disks. Like, just give me everything. Okay, so imaging core storage can be a little tricky. So 2-disk core storage ROMs requires you to image both physical disks if you're using any other imager but a Mac-based imager. Most common forensics tools cannot combine those two physical images that we create, so you got to bring it back to a Mac again. So how do you do it? All right, that's how you do it. Okay, so I'll be having a test at the end of class, so you guys can write this down. All right, so what it is, oh, by the way, this is on our website. So if you go to our website and go to our blog, go to the very, very last one, and it says Mac Forensics Best Practices. If you go there, you can download a cheat sheet, which is a summary of basically our 2 training courses, Mac forensics training courses. So I'm not going to single out any particular U.S. agencies, but I did 2 weeks of awesome training of like Mac stuff. And like, yeah, can you just put that on like 4 pages for us? Like we want the Cliff Notes. So I did. So it's available to you guys. And this actual command is there. So what we're doing with this particular command, I'm just simplifying it for you, is we're using HDIUtil command, so hard disk utility, to attach or mount the first piece, the SSD version, and the second piece, which is the spinning platter, right? So that actually combines it on the Mac. You can actually do it like as you see here with the flags, read only, no mount, okay? And then you can actually image it. You can image the combined. So Mac will do its magic when both of the pieces are there. That's the great thing about Mac. When you put the pieces there and put them together, it goes, oh, I got both pieces, let me combine it for you. And its core storage takes over and it sees it as a volume. And then you can image it out. You can image it out again and everything's combined. But again, a Mac has to be involved in the process. Okay. Now, APFS. So any questions about core storage?
Real quick, on your website, where is that? Which form?
So go to blogs, go to the last page, to the first entry, which would be the oldest, right? And it says Mac Forensics Best Practices or something like that. And there's a PDF you can download, which is a step-by-step guide on doing Mac Forensics. Okay. All right. So let's talk about APFS. So Monday, what's today? Today's Wednesday. So Monday, 2 days ago, I'm losing track of time. That's what happens when you travel a lot. All right, so on Monday, High Sierra was released. Bam, it's here for everybody. So our team has been playing with the beta for a while, just to see what's coming. I'm just going to tell you this: if you're using some of our tools right now, you're like, when's the new update's going to come out? We've learned that, and I confirm this with colleagues that I work with or know from Apple. There's always stuff going on with the betas. Things are changing constantly. You know, a beta period is a time of testing things to make sure things work right. So we try not to base our tools or like be ahead of the curve and base our tools in the beta, especially the forensic stuff, because what we found in the past is like if we base everything on the betas, as soon as the final options release, things just break. It's like, oh, not working. We changed our mind. We're doing this differently now. So the final version's out now, so we are currently updating all of our tools, and the updates will be out soon. Specifically new stuff for APFS. So what we have here, let's talk about APFS, Apple File System. So Apple File System is the new file system for Apple, and it's intelligent. It's intelligent design, and I hope so because it took them 30 years to get to this point. It's faster. It saves you a lot more space. You can utilize like multiple volumes or disks, right? Can utilize each other's space if they're not using it. It's really good. It's faster in the sense like reduplicating or backing up your disks. It's almost instant in that sense. So a lot of things are faster. Instead of like making a duplicate and actually taking two particular files, right? Like if you're making a duplicate of a file, you imagine it just creates a duplicate of a file and it writes a duplicate to another area on the disk. Doesn't work that way in APFS. It just makes another pointer. Oh, there's that one's here and you want it here. Okay, we'll just point back to both files. So it makes it really simple. So it's optimized. It's optimized for solid state drives. That's the nice thing about it too. All right, and then it's utilized across all their devices. So it's utilized across Mac OS, iOS, tvOS, watchOS, and Toaster OS. If you know Apple toasters. So you don't have it yet? Okay. All right. So now. It's got the ability to create snapshots of the file system, and that's used for Time Machine backups, right? So Time Machine is Apple's automated backup utility, and it's quick. It's like instant. You can back up gigabytes of data like in an instant, just because of the way it works now. It's kind of cool. It's got, bad for us, right? Enhanced disk encryption and additional data integrity. So you can actually use with multi-key encryption, you can actually, like, we know about disk encryption, right? Now imagine individual file encryption. Okay, so like even if you decrypt a disk, each file is encrypted individually. It's scary, right? Not good. So not good. So yeah, let's not go there right now, okay? So now, APFS was released in like a limited functionality in 10.12, so Sierra, which is what probably most people have unless you upgraded as of Monday. So Sierra was 10.12, the recent system, and then High Sierra was basically the new version that was released. So the one that was released, the APFS that was released in 10.12, had limited functionality as opposed to the full version of APFS that's actually released now with 10.13. So just keep that in mind, because this is important. If you're using an older system, okay, if you're using an older system, especially like if you guys aren't upgrading your Macs, lab Macs, if you have them, okay, you need to upgrade. I'm telling you right now, if you're dealing with APFS, you have to, and write this down, okay, you have to upgrade to 10.13. You got to. If you're going to deal with APFS, you must upgrade, okay, to 10.13. All right, that's your only option, okay? Now let's try to understand APFS here. So I tried to make this, and I grossly simplified it, okay? So as the term we used, right? Cop-proof? Right, just kidding. All right, so now, I was a cop, I can say that. All right, so I grossly simplified this. Some people give me like mean looks like, that's not funny. All right, so here's the deal. Let's look at this as a traditional HFS or Mac OS extended formatted disk. So like the old way. So this is the old way. And we have two volumes or two slices on here, slice 1, slice 2. So, okay, let's assume, looking at this, this is a 1 terabyte drive. And again, I'm cutting out a lot of stuff just to make it simple. We have a 1 terabyte disk. And the first volume, the first partition, the first slice is going to be 300 gigabytes in size, okay? The second slice, the second volume, the second partition is 200 gigabytes in size. So for a total, right, of 500 gigabytes. So we said first volume partition is going to be 300 gigabytes. Second one's going to be 200 gigabytes. That's a total of 500 gigabytes of space that we use. So free, the space that we have free, minus 500 from 1,000, right? We have 500 gigabytes free. So we used half the disk, right, with what we have here. All right, so the volumes that we created when we initialized the disk or created our volumes, those are fixed sizes. They're fixed. Okay, so it's 300 and it's 200 and that's it. So as we see in slice 1, okay, only 150 gigabytes is left unused. Even though there's 150 gigabytes of unused space on the first partition, you're still taking up 300 gigabytes of space, right? Same thing with slice 2. They were only using 150 gigabytes in that partition, so we have 50 gigabytes unused, but we're still taking up 200 gigabytes of space on the disk. So no matter what you put into those partitions, okay, you're still taking up 500 gigabytes of space. Not so smart, right? So I guess back in 30 years ago, that was like, this is awesome, we're the best. Okay, well, obviously things move on and we get smarter and better. So Apple did a great thing. So check this out. Enter APFS. So in APFS, you have, and again, grossly simplified here, so let's not get into the details. We have a 1 terabyte disk. On that 1 terabyte disk, we make a 1 terabyte container. And again, there's overhead for system stuff, but I'm just making it simple. So let's assume we made a 1 terabyte container on the 1 terabyte disk. All right, now, same thing, the first slice. I only used 150 gigabytes of stuff and 150 gigabytes of data on both those partitions. So 150 gigabytes plus 150 gigabytes, that's 300 gigabytes. I still have 700 gigabytes free. Each one of those partitions can grow in size and expand. They're basically, they're like sparse images or bundles, right? So they can actually grow and shrink. So this is a little bit different now. This is where we get into what I call Inception forensics. So if you've seen the movie Inception, where you tunnel into someone's dream and into someone's dream and you keep going, this is where we're going with this, okay? So this is going to be funky. So you got to understand this concept. Stop thinking, I'm just telling you right now, I'm looking at people in here, stop thinking of traditional forensics and traditional disks. We're dealing with virtual stuff now. Virtual physical disk, virtual volumes on the virtual physical disks. It's all not going to make sense in a second. Like it's all just forget what you know. Like it's like the Matrix, like I said, just forget what you know. All right, we're going to have to think different. Not to use a pun from Apple, but yeah, think different. Let's try to understand this. Stop laughing. All right, Manny's laughing at me. All right, so now, what you're seeing here, like this is actually a screenshot from the new disk utility. So what you see is this, do you want to add an APFS volume to the container, right? So basically APF volumes share storage space with their container, provide a name and format and click add to proceed. So this is the options you get for actually creating an APFS volume within a container. So can you only use can you only use APFS as a partition or a volume? No, 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 no. You can use anything you want. Like the same options exist that exist before. You can use exFAT. You can create an exFAT volume. You can use FAT32 or FAT volume. You can use those other ones. Okay, but think of it differently now. So think of it like this. If you have, let's start with the physical disk. You got a physical disk. On that physical disk, you have to make a container. So just a bucket, like we're putting a bucket in the disk. And depending on how big your disk is, you can make your container as big as the disk, or you don't have to. You can put multiple buckets inside your disk as long as it, think of the containers now as the old partitions. Like that is like your container is fixed in size. Your container is fixed in size, not the volumes inside the containers. So your container is fixed in size, not the volumes inside the containers. The volumes inside the containers can change, but the container is fixed, okay? So how does this apply in the real world if you're totally confused? Everybody knows about boot camp, right? So a boot camp, load Windows onto Mac. Let's assume that you wanted to do it this way. If you wanted to segregate space, so like you don't want like your Windows taking all your space from your Mac, like no. Windows likes to store lots of files, so I'm not going to let it encroach upon. We're gonna keep it evil. We're gonna be fair, right? We're gonna give it like a 1 terabyte disk. So okay, Mac's gonna get 500, and Windows is gonna get 500. Now, if you just did one container on that disk, that 1 terabyte disk, either Windows or the Apple side can go back and forth in size. So Windows could take more of the space than Apple's operating system would take more of the space. But to stop that from happening, you would create 2 containers. This container is 500 gigabytes and this container is 500 gigabytes. And then the volumes inside those containers can share space. Okay? So think of it that way. It's just a different way of thinking. It's not so bad. Until this. Okay, I tricked you guys. All right, so until you get here. So when you get here, now this is what I'm trying to say. A single or multiple container can be created on a physical disk. The containers are fixed in size, the containers. Inside those containers, you can place volumes. Okay, you can create multiple volumes. And it could be any type of file system you want that Apple supports inside those containers. Most of the times, I'm going to imagine that you're going to create one container on one disk, and then you're going to create your volumes inside those. That's probably going to be the normal way of people doing stuff. Okay, so when you actually get these into examine, you're probably going to see one container containing multiple volumes inside, probably not multiple containers. But again, you might have some power users out there that will do that, okay? Because it does make sense. If you really want to segregate your boot camp from your Apple and make sure that they don't over encroach each other's space, then that's what I would do, create 2 containers. Now let's look at this little chart that we have here, right? So again, we use the disk-util command here. It says disk-util APFS list. I'm trying to get over here so you can see it. Disk-util APFS list is the command, all right? So now, let's look at this. Let's follow the volumes, right? Let's follow the trail here. And this is what gets tricky. So the reference disk, the APFS container reference disk is disk 2. And we have the entire ceiling, the size, like how far can this thing grow? And we see it's about 250 gigabytes, okay? 250 gigabytes. And it tells you what's free and what's used. So now, if you get down a little bit below, I have to map out here a little bit. Sorry about that. So we have a physical store. It says disk 1 slice 2. Okay, another one that says disk 2 slice 1, disk 2 slice 2, disk 2 slice 3, disk 2 slice 4. What are we looking at? Like what the heck is going on here? Okay, so now we have to kind of look into this a little bit deeper, and this is where it gets tricky. Okay, so the physical store disk, okay, the store is we see the container reference is disk 2. Do we see any other disks in here? So we see a disk 1 and we see a disk 2. So disk 2 is the APFS container. So disk 2 is the APS container. Disk 1 slice 1 is the actual physical store disk. What do I mean by the physical store disk? That's the actual physical disk itself, right? We start with the naming convention of 1. So I can tell you what I did here. I have my internal boot drive, which would be disk 0. Then I connected an external drive, which is formatted with APFS. It's got a bootable Mac OS on it, High Sierra, right now. So that's what I did. So my internal drive would be disk 0. My external drive would be disk 1. Disk 1 slice 2, okay, is what is being used, okay, to make the APFS container. So that's the actual volume. So we got a volume that becomes an APFS container. And inside that container, which has now become disk 2, virtual disk 2 container, right? So the container, we have different slices within that. So we have disk 2 slice 1, disk 2 slice 2, disk 2 slice 3, disk 2 slice 4. And we see them labeled as no specific role according to this command: pre-boot, recovery, and VM. So I'm assuming your recovery is your recovery disk. Okay, VM I found out is like a virtual swap disk. So this is really smart from Apple as well. And if I'm saying this wrong, I apologize. It's just my limited research I had time for. Let's assume you have 8 gigs of RAM in your system and you need more, so you can actually utilize that space. So that's basically going to be extra RAM. So like RAM capture type stuff, something to look at in the future. All right, so then pre-boot, it's going to be pre-boot stuff. And then the one that says no specific role, notice the name. It says High Sierra. Guess what I named my volume? High Sierra. So do you see where I'm going with this? You got a physical disk which has a partition on it, a physical partition. That physical partition becomes an APFS container, and inside the APFS container, you have multiple volumes, and one of those volumes is where the user's data is stored. Whew. Do you want to quit yet? You guys ready to retire? Do you see where I'm going with this? What do we do? What do we do? So that's what you're all here for, right? What do we do? Like, Steve, how are you going to save us? Please save us. I don't want to deal with this. Okay, hang tight, we'll get there, okay? So a view from above. So we're using another command here, okay? This other command here is just straight out disk util list. It's a really good command to do. And we can see there's my disk 0, which is the internal, okay? That's my internal disk. That's just my regular, and then that's a HFS disk, right? So it's an HFS disk. Disk 1 is my external disk, which I told you out. And if you see right there, it says disk 1 slice 2, Apple APS container disk, and it says disk 2. So that slice becomes disk 2. Drop it down, go to disk 2, which should be a physical disk, but it's not a physical disk, it's a virtual disk because it says synthesized. Okay? Sounds kind of like Herbie Hancockish. Yeah, synthesized. What's up? All right, so now go inside to that synthesized disk itself. We have more volumes. So you have a partition that's being used as a physical disk that's containing more virtual volumes. And those are the way, again, in the grand scheme of things, this is an excellent design. It may be a little confusing. You'll hopefully wrap your head around it. But look at the space that's being used. Okay, so the High Sierra is only using 15.8 gigs. Okay, the other ones are using megabytes, lower gigabytes. I mean, just small stuff. They change inside, and all those volumes that you see right there share that same container. Okay, and each one can share the space, the unused space, so it only takes up the space it needs. The question is, from a forensic examiner's point of view, what the hell do we do? Like, what do we image? Like, where are we going to go with this? Okay, I told you I would save you, okay? And this is not like a sales pitch, but I'm telling you, it's I think the only thing on the planet right now that's going to help you. Okay, if you want to do this the easy way, I'm going to use Recon Imager, which is our product. It's a Mac-based imager. Recon Imager actually it's a quintuple, I did say quintuple because it's fun to say, a quintuple boot environment. Okay, so it's 5 different boot options. Okay, so we have 3 versions of Paladin, so it's basically like our Paladin Pro, and it's got all those versions, like full 150 forensics tools and, autopsy and all that great stuff, and our Paladin imaging tools, our Paladin toolbox, and triage and all that good stuff. It's all in there. Then we have 2 different versions of macOS, and maybe there'll be more depending after our testing. But there's 2 different macOS versions, so you can support any Intel Macs from 2007 on upwards. And here's the important point. Using a Mac-based imager, the Mac OS is going to do the heavy lifting for you. It's going to interpret this stuff natively for you, so then you can interpret stuff. Okay, everything's interpreted for you. It makes it easy. So what you can do is you can handle core storage natively. You can handle APFS volumes natively. You can use the diffusion drives, right? You have fusion drives and the derived from, right? You get 2 disks that make 1 disk, all handled natively for you. So the hard part has been done. You don't have to do it afterwards. You do it before. Okay, if you have a file vaulted drive, and file vault does exist in APFS, it's still there. It's still there. You can decrypt the file vault if you have the recovery key or password, because it all works the same. You can enter it and decrypt it. It makes a new decrypted mount point, make a decrypted image of file vault. You don't have to worry about it later, about it putting file vault into your other tools. Now, here's the other part. When we get into APFS, it gets confusing. So let's look at Recon Imager here, a screenshot with it, okay, with Fusion and Core storage drives. So what you see here is the actual disk 0 and disk 1, which makes disk 2. And I know it's hard to see, and I apologize for this, but what you see, the two oranges, we've identified the core storage volumes for you, the core storage volumes. We highlighted them in orange, okay? That's the SSD in the spinning platter, right? So the two oranges make yellow, okay? You guys learned that in school? Two oranges make it yellow? In my world, it does. Okay. Oh, okay, got another question.
How do Recon and Recon Imager differ?
Okay.
I'm already licensed for Recon.
Question came up is how does our Recon for Mac OS product and Recon Imager different? The answer to that question is the Recon for Mac OS is our analytical tool. So if you make the image, you analyze it in Recon for Mac OS. On Recon for Mac OS, which is an external drive that we have, it has Paladin Pro in it, so you have the Paladin tool sets on it. However, it's the analytical tool. Recon Imager is the imaging tool with Mac-based imaging tool. So that's the answer to that question. So now in this example here, we have a Fusion drive and core storage. The two oranges make the yellow. Okay, so that's the one. If you want to get everything put together for you, you would then go into the imaging tab and image that yellow slice right there. So that mount point, disk 2. Disk 2 would be what you image, and then you can throw that into any forensics tool you want because it's already put together for you. Okay, the reds that you see there are stuff that's actually mounted read and write. Green is read only. And then if you go down a little bit below, you're just going to see other drives that we have attached, including our boot drive. Now let's look at this from the APFS world. Okay, so what we have right here is, this is actually looking at, let's see here. We have disk 0, which disk 0 slice 2 has an Apple core storage volume. That's the actual container. That's the actual partition used to hold the container. The container itself is as disk 1. And so, oh, I'm sorry. Go back down there. Disk 0, and I'm trying to find it myself here. Oh, I'm sorry. I'm looking at the wrong disk. So because I'm looking at, I was using High Sierra to do this. So we got two actual APFS disks here. We have the internal APFS disks and then the other one. So let me put glasses on. Then I could probably help myself and see better. All right. So what we have here is we see the APFS container. So we have disk 3, which is the external drive. So if you look at disk 3 and disk 4, they both say the SSD T5. That's our Samsung drive. So disk 3 slice 2 is going to be the Apple APFS formatted volume. And then inside that, you have your container file. So it's interpreted as disk 4. So then you have your different container files. The one that's highlighted in red that says High Sierra is the virtual volume. Now, again, if you're using this and putting this back on a Mac, then it's fine to actually just image the physical disk. So now the problem is, if you're going to put this in the Windows Forensics tool and you image the physical disk, nothing in the Windows world, the Windows Forensics tool world, understands APFS, right? So that's a problem. So what do we do for you? This is a very, very important concept here to understand, okay? The concept to understand here is this. We created a button in here for you that allows you to create logical imaging of those containers, okay, of those containers. So you all can import directories, right, logical directories into your Windows Forensics tools, right? The answer is yes. So you can do that. So we made it to a point that we can logically extract that information for you and, hash it and preserve it and all that good stuff from a forensic point of view. And then you can import it into any tool. So what I'm trying to say to you is the only thing I can do to help you, and it's not about the money, is to actually help you continue working. So if I want to be really mean right now, I could say, I'm sorry guys, you have to use Recon Imager and Recon for Mac OS to process APFS, and I'm going to be rich and drive around Tesla, right? But that's not reality, and that's not the way things work. You guys need to do your job. I'm speaking to law enforcement out there, and most of you guys have Windows Forensics tools. I'm not going to just benefit myself, at your expense, and we're never going to do that. That's not what we do at SUMURI. So what we've done is we created an option in here to be able to export that APFS data for you into a format that you can actually input into any Windows Forensics tool. Question?
Does target disk mode present the entire disk, or does it have limitations?
Okay, so the question is, does target disk mode, I'm assuming, work with APFS, and is there any limitations to that? That I still have to test with the final version. I haven't had time to test that with the final version of APFS that's included in High Sierra because it came out 2 days ago, and I'm preparing for this. So that I have not tested yet. We'll have to check and see. But speaking to some of the Apple representatives here, there have been changes to the binaries that will show you what's in there. So I have to research those binaries, and if I can find a way to do it, and if there's anything helpful, we'll definitely put it out. We'll definitely put it out. Yeah, but I'm assuming a Mac. Apple's trying, from what I understand, trying to make everything work the same as it did before, but the file system has greatly changed. But they're trying to make the commands work like they did before, and so I have to test all those commands again. So hopefully that answers the question. So again, just going back to this, my whole point that I'm saying here is that you gotta use the Mac the Mac has to be in the equation again. So it's either a Mac-based imager or bring it into Mac. And when it comes to APFS, again, the same issue. It's just easier to use a Mac-based imager to do this right now. It's just easier to do it. Just really quickly here, I'm just gonna go over to my webcam that you're gonna see here in a second. So I attached, we have pretty much a brand new MacBook Pro with a touch bar. And I know it's kind of, I can see the touch bar stuff there. But what you're seeing here, don't get sick when I'm moving this around, it's supporting Apple APFS right now, and that's version 102. So that's the current version. So you can make physical images of that and import it into, a Mac, and it's gonna work. Okay. So, but we're gonna add, we're working on it right now, finish up the finally testing with version 103, which is going to add additional support to support all you Windows guys out there. So I just want to go ahead and show you that really, really quick. Let me go back to the presentation here. All right, so here's an example of it being decrypted, file vault being decrypted. So we have file vault being like, basically you would select the actual partition that's anything that's file vaulted, that's been identified as file vault. You'll see a decrypt button pop up. You can add the option for password recovery key. It's going to use the Mac operating system again to mount that as a decrypted volume. So where this comes from is it's really simple. Using a Mac to do a Mac is simple. Okay, it just works. If you are file vaulted, if you have a file vaulted system and you log in with your password, everything's unencrypted. So it's really simple. If you're using the Mac and it sees a disk that's file vaulted, you enter the password, it decrypts for you. Now you just image the decrypted volume. It just makes it simple. Just keep it simple. All right.
Here's another one.
Oh, another question.
Oh yeah, is it mandatory for a Mac to be used in the process?
So the question is it mandatory for a Mac to be used in the process? So as I've been saying, which was on the first one, a Mac has to be involved in the equation. I am not saying that you don't use Windows Forensics tools, because the purpose of what we did with Recon Imager is to give you something in a format you can import into your Windows Forensics tools again. You can catch if you're here, you can catch my other lecture. It's going to be about, it's going to have information on Apple extended artifacts. So you will, if you don't use a Mac to process a Mac, you're going to lose a lot of evidence. You will lose a lot of evidence. And it's just faster to do it with Mac-based tools or on a Mac system. Because Mac looking at Mac makes sense. Windows looking at Windows makes sense. Linux looking at Linux makes sense. So hopefully that answers your questions. And we support all the standard formats for you as well.
Is the recovery key still available in the recovery HD partition?
In the P list?
Yeah.
For APFS, you mean?
Yeah, I use password to do it.
So I don't know that exactly to answer that question. So to repeat the question, is the recovery key that was used to like maybe use a password recovery tool to dictionary or brute force attack the login password, is it, or the file vault volume, is it still there? The encryption has changed. The encryption scheme has changed. So the decryption tools or password recovery tools are going to have to change as well. I'm sure there's going to be a curve for them to catch up. From what I understand, Apple's trying to keep things the same, but when it comes to encryption, they're tightening it down. And I'm sorry to say this too, but from what I hear from my sources, it's only going to get worse with Apple's security and encryption. They're Apple's really big about security with their products, and they're not going to make it easy for us or easier. They're going to make it harder. So, I'm telling you this now, but it's actually just going to get worse. So any other questions? Yes.
So are you doing all of your imaging through target disk mode, or how else are you imaging?
Okay, so are we doing the imaging through target disk mode? And the answer is no. We're doing it with this. So this is our new Recon Imager. So for those that bought the old one, I apologize. What it is, and let me bring up the camera here for you. Oh, that's not my camera. That's my camera. Let me see if I can do it. That is it. That's Recon Imager. And if you see right here, Type C. Ooh. The other side is Type A. Okay, so you can slide it back and forth, Type C or Type A. Okay, so you don't need adapters to plug this disk into the Mac. Okay, and we boot, as you see right here on Manny's laptop, you just plug it in. This is our old Recon Imager. It's with an adapter, and it's plugged into it, and we hold down the Option key. We hold down the Option key and boot to Recon Imager. Okay, make sure there's no firmware password. Okay, and then we just boot into our Mac OS environment. Our Mac OS environment. Okay, makes sense?
Well, so I have the suspect computer, and then I plug in.
Recon Imager, or an image, a Mac-based imager, yes.
Yeah, so say your Recon Imager, I plug that into the suspect's computer and then boot it up.
Yes.
And then that'll give me put me to a place by place.
Yep. Then you slave off an external drive, and then you image away. All right. If you image the encrypted one. All right. So there's another question that came up, which is a kind of tricky question, and it's different with APFS. If you image a decrypted volume with like if you decrypt it and you image it, are you going to get deleted files? The answer is not likely. Not likely with what Apple does. So hey, really quick, if you guys can, we're gonna end the live stream portion of this, but I for you guys that are law enforcement, I have some information to tell you that I can't put out on the live stream. So just hang tight for 1 second. For those of you following along, thank you for following. There's information on there and following us on all of our different social media channels. We're going to do more of this stuff in the future, so please find out or pay attention. I'm going to end the live stream now, or I think my guys down at the back will end the live stream now. And thank you for joining us. And I want to talk to you guys really quick.